I'm John Wilker, the organizer of 360 IDEV. I hope you enjoy this session recording, but first I wanted to mention one thing. We've served the community since 2009, and over the past few years we've had to take on debt in an effort to keep the conference alive. After several unforeseen challenges, not the least of which is a pandemic of indefinite duration, we've had to make the hard choice to end the conference as we're now facing over $100,000 in debt. As a result of requests from the community of how they can help, we've created a GoFundMe campaign. If you're inclined and able, please consider donating to help keep 360 IDEV going. The QR code after this will link you to the campaign. Thank you. Enjoy the recording.
Time got away from me a little bit, but I guess we should get started. I want to try to get through this so I can get to questions at the end. Hopefully you'll have some. Otherwise, it might be kind of embarrassing. All right, are we ready back there? All right. Whoa. Okay. Hello, everyone. Thanks a lot for coming to my talk about SQLite, the everywhere database, as I'm calling it. I'm Nathan, and you can find me on Twitter or other social networks as Eror. Unfortunately, my middle name does not start with an S. Joke I hear all the time. But it would be a lot cooler if it did. A little bit about me before we get started. I'm one of those lucky people who used to build AppKit apps for myself for fun back in like the early 2000s and got really lucky when Apple released the first iPhone SDK. And then I immediately started working on iPhone apps and teaching Objective-C to other developers, and kind of the rest is history. And these days I'm a lead iOS engineer at Audible. And I'm really excited to be back here. It's been 3 years since I've been here, and 3 years since really I've been anywhere, like a lot of us. But I think this is the best Apple platform developer conference outside of DubDub, maybe even better than DubDub in some cases. I look forward to it every year. I'm glad you're all here. I'm glad it's still going. In fact, I gave my very first conference talk at the first Denver 360 IDEV. It was 13 years ago now. So I can't believe it's been going on that long. But that was then. This is now, and now it's time to talk about SQLite, which you probably heard of, right? Yeah. And you're probably using it, even if it's just as the backing storage for core data. And in fact, before we go forward, I want to be clear that this talk is not about using SQLite because core data sucks. I actually love core data, probably more than a lot of people do. I think it's expressive and powerful, and it's a wonderful object database. And you should absolutely use it in your iOS apps and your Mac apps and your tvOS apps or whatever. But SQLite is also expressive and powerful, and you might have a problem or a specific use case for which it's the ideal tool. But only you know that, and hopefully I'll be able to help you navigate those waters and make those decisions today. All right, so now that's out of the way, I'm gonna spend the rest of this talk answering these 3 questions. Hopefully they're the ones that you had in mind, but if not, I'm gonna do my best to leave time at the end for you to ask your question, but you can always come up to me afterwards, reach out to me on the Slack or on Twitter or anywhere else you can find me to ask me questions. So question number 1, is it really everywhere? It's close. It's about as close as any single piece of software out there besides maybe like zlib or libc. It's in all of Apple's OSs as well as Android, which means it's on pretty much every smartphone. It's also a core library in Windows 10 and 11, and it's in all the major browsers, which means it's also on most computers. It's also in a lot of, if not most of, TV set-top boxes to drive things like the those channel guides and things like that. It's also in a lot of automotive multimedia systems and in a lot of embedded devices, things like routers and edge IoT devices and stuff like that. It's also in the Airbus A350 and somewhere in the avionics software. I don't know where. Apparently it's not a safety critical thing, but it is in there. It is also in space, aboard the International Space Station. It's not built into any of the software on the station. It's actually some Android devices were certified to go into space, and it's on those. But you can still count it as being in space. What? Oh, yes. And iPads are up there too, yes. Hopefully. I don't know if it's on, I don't know if it's on the Mars rover or not. We'll have to ask someone. All right, so we know it's a lot of places. So the next question is, what is it? Well, it's a lot of things, but mainly it's a SQL database engine. It's a lot like MySQL or Postgres or SQL Server, but it's also different from those in some very key ways. The first one being it runs in process, embedded in your app. Right? It's distributed as one big C file normally that you can just drop into your project, especially if it's like a C-based project or C++ or something like that. Hit the build button, you're done. You can use SQLite. And it's like this huge 200,000 line C file, which isn't the one the developers actually work on. They work on it in individual files and then have a build process that generates what they call their amalgamation file, which is the huge one. And apparently that helps with compiler optimizations and things like that. Also just makes it easier to distribute. So you can compile it into your app directly. You can compile it as a static library or a dynamic library. And on Apple platforms, it's already distributed on the system as a dylib. So all you have to do is import SQLite 3 at the top of a Swift file. You're done. It also has zero configuration. Since there's no client or server like with Postgres or SQLite or SQL Server, and since there isn't one, you just open up a connection to a database file and start executing queries. You don't have to set up any hosts or there's no permissions or anything like that. If you have permissions for the file on the file system, you can do everything immediately. And each database is a single file, which is portable across platforms, regardless of anything like endianness or architecture or anything like that. So you can create a SQLite database on a little endian 32-bit Intel machine, take that exact same file, drop it on a 64-bit big endian ARM, like an M1. You don't have to worry about any of the endianness, anything like that. It just works. And it's all handled internally by SQLite. Also, the SQLite format is really well-defined and stable. Which basically means for you, right, that newer versions of SQLite can read and write files created by older versions, and you don't have to worry about migrating your database when you get a new version, like frequently happens with client-server databases. And this is something that the SQLite developers are really committed to maintaining. It does occasionally impact how newer features are implemented, but that's a trade-off that the SQLite teams decided they want to make. Keep the compatibility and keep it stable. So the file format is never going to change. At least that's what they say. And it hasn't in the 22 years that it has existed. So you can be pretty confident that it's going to stay that way. But who knows, it might one day. Another thing about SQLite that really I appreciate is it's one of the most well-documented software libraries I've ever worked with. Commercial or open source. The SQLite.org website not only has extensive documentation on how to use the database, it also has detailed docs covering how it's implemented internally, as well as the heavily commented source code. And they're real useful comments in the source code. They're not, just junk comments. So it's very heavily documented, very easy to kind of dig into and if you're preparing a talk for a conference like this, it can also be a little bit of a problem because every time I think I've got everything figured out, I'll find something else that's interesting that I want to talk about. So it's probably gonna have to be like 5 talks. Another thing is it's very well tested. In fact, testing is a bit of kind of like an obsession for the SQLite developers. The project has like 4 test harnesses, multiple test suites, which run hundreds of millions of automated tests per platform per release. Among many other things, the project has 100% test coverage for all code branches at the machine code level, and a lot of other things. So this is a screenshot from the SQLite documentation. This is a specific document on how it's tested. So if you're interested in this, I recommend checking out this page and kind of reading it. It's kind of inspirational and also a little crazy how well it's tested. For most software projects, I'd say most of this stuff is overkill, but It kind of makes sense for SQLite. It's maintained by a team of 3 people supporting, a piece of software that's deployed to billions of devices. So if there is a bug, it will be found, and they try to find it first. Something else that's kind of unique with SQLite as far as open source software goes is it's, especially for something that's so popular, or it probably contributes to its popularity as well, is that it's in the public domain. There's no GPL, MIT, or Apache license or anything to deal with. Every line of code and all the documentation is 100% in the public domain. In fact, all of the authors, the code authors and documentation authors, and the representatives of the companies they work for have actually signed affidavits dedicating their contributions to the public domain, and the originals of those affidavits are stored in a safe at the creator's office. So it's 100% public domain. No one can claim any of it. You can do anything you want with it at any time. I thought that was interesting. That's really taking it to the next level. All right, so that's kind of what the project's about and how it's, how it works, how it's structured. There's also some really useful features that you get when you use SQLite. I wanted to kind of cover some of those first, or now, I should say. First of all, the SQLite transactions are ACID transactions. It's atomic, consistent, isolated, durable. Basically what that means is all changes in a transaction will either occur completely or not at all. And even if in the act of writing the changes, you lose power, or the app crashes, or the OS crashes, or anything like that, you still don't lose data. You might lose stuff you were in the data that was being written in the transaction, but it will not corrupt the database. You will not lose any other data. And SQLite also can automatically recover from most of those failures because it writes out the transaction before it does the writing, so it can actually, in most cases, can still recover what was in the transaction as well. Kind of depends on how you configure the database, which is very nice and very useful on, say a mobile device, or especially if you're, in a place like space, right? So it also has flexible typing, which is a pretty unique thing for databases in general. I don't know of any others that do this. Its type system is kind of drastically different from most database engines. You can define columns to have a type, but SQLite doesn't require the data you store to be of that type. It just stores it. It really takes the types as a suggestion for how the data should be stored, but it'll happily store it for you, regardless of what you said you wanted in there. So it's, and there's a really long document in the documentation about kind of how it works. But you actually, in a lot of cases, don't need to define types for any of the columns if you don't want to. It's not a requirement to have a type for a column. You can just put anything in any column of any size. Even if you define like a column to have a certain size, it'll still happily write 1 gigabyte record into that particular column. It doesn't care. You might also know that, so this is a table from the documentation, which kind of shows if you define a data type, that these are the data types that it can take, and it will massage into whatever, into the column data type is kind of, it helps it decide how it wants to store, or how it's going to store the data. So if you give it any of those things, it'll try to convert into that. And if it can, it'll still store it. But you might notice there's no Boolean up here. There's also no date time up here. Those are 2 types that it does not have. Boolean, use an integer. It's just like C, 0 means false. Any other value means true. As for date times, you have 3 options for how to store your dates. You can either store them as a Unix timestamp, like a Unix epoch timestamp, which will be stored as an integer. You can store it as a real or float, which is usually done for a Julian date time, which I don't know anyone who uses that these days. Or you can store it as text, as a string, as an ISO 8601 formatted date string. So there's no actual data type for dates, but there's a whole suite of date time functions built into SQLite where you can use to convert back and forth and do date calculations and things like that. So what else? Where am I now? Okay, yeah. So it's also, SQLite is also safe for concurrent access. It's built to be thread safe. There are different modes that can be a little more thread safe than others, but the default mode is that way. And it's a single writer, multiple reader kind of system. So even though it's concurrent, you can have as many readers as you want across different processes, different threads, whatever, different database connections, but only one writer at a time. So whenever a write transaction starts, it locks the database, and any other writes that try to start during that lock will immediately get an error back saying the database is busy, so you can retry later. Or you can just not do it, however you want to handle it, but you have to handle it. SQLite also implements almost all of the SQL standard, plus a few non-standard extensions, which are implemented by other popular databases like MySQL and Postgres and things. But SQLite can also be extended with custom functions like scalar functions, aggregate functions, table valued functions. There's a whole extension interface. So you can have your Swift code called as part of a SQLite query. So if you're integrating SQLite into your app, say you have some proprietary algorithm you want to run as part of like a where clause or an order by clause or something like that, so that maybe it's a huge data set that you want to filter based on some custom logic that you have written in Swift or C or whatever. You can use that function inside through this interface. You can add that function to SQLite, use that in your query, and then it'll do the filtering by calling that function. You can also use it for the collations, for sorting. That way you don't have to like load everything into the memory and then do the filtering later. You can do it all as part of the SQL query. And there's lots of things you can do, obviously. It's a pretty flexible interface. And SQLite also comes with some built-in extensions that are pretty powerful. Namely, there's the JSON extension, which we're going to look at, full text search, sessions, which are really useful for certain cases where, so the session extension will allow you to take change sets, to make change sets from different snapshots of the database, and then replay those on another copy of the database. So if you have one SQLite file, if you have two SQLite files and one of them diverges from the other, you can take a snapshot of it and apply that to the other one. It also has an RTree extension for doing high performance range queries. It's really useful for things like geospatial data, right? So there are a lot of not a lot, but there's 3 or 4 extensions that are built to make SQLite an entire like geospatial database built on top of the RTree extension. And we're going to take a look at some of these extensions here in a minute. A few other features, of course, there are indexes in SQLite, and they're pretty useful. Obviously, if it's a database, the indexes are pretty important. It supports partial indexes, which can, for example, only include rows in the index if the column being indexed is not null, right? So it basically allows for kind of sparse indexes. Or it's maybe not null, maybe satisfies some other expression. But it's a useful thing for performance tuning, limiting the size of an index for the size of your database or for the actual search. It also supports covering indexes, which was kind of inspired by a feature in MySQL, where you can store extra data in the index. So if there's an extra couple fields you want to pull when you're using a certain index on a query, then if those are the only things you're asking for, it doesn't have to make the extra hop back to the original table to fetch those out. It'll just take it from the index and basically cut the query time in half. So it's useful for very specific things. But that's the covering index. And then another one that's also useful is you can actually create indexes on expressions, which it can be any expression. It can be a calculation of some kind, a sum, a mathematical expression, or any functions that you might have added. which is useful as well. And we might have a chance to look at one of those here in a little bit. SQLite supports triggers and virtual tables, and then I'm kind of rounding out my last list of my truncated list of useful features. There are a lot more, but this is all I could put into one talk and still get to some examples. You can connect to multiple databases per connection. So this is really useful, and I've actually used this before in apps. It allows you to query and join across tables from different databases. So for example, say your app is for flight planning for pilots. So pilots are frequently in areas with bad internet or no internet, and the app needs to work offline. So say you're a pilot who wants to plan a trip, and so you need to know where all the airports in the world are in order to do the trip planning. Well, the airports in the world is not a data set that changes very frequently, right? There aren't new airports every day. And old airports don't go away every day. So it's a pretty static data set. So for something like that, that's a mostly static data set, you could just ship the whole SQLite file with your app or download it. And then you can, as part of your regular database connection with the rest of your database, you can also attach the airport database, and then you can join across the tables in your kind of regular app database and the other database for useful queries, right? You combine that with a session extension that I mentioned earlier, where you can send out deltas of the airport database, so you can kind of keep it in sync at all times without having to download the massive file every time. So a pretty cool feature, useful for kind of on-device stuff. SQLite obviously is really good for edge devices. That's why it's used on there a lot. I'm going to blow through this really quickly, but I kind of wanted to explain how it works, how like the anatomy of like a query really quickly, and then we'll look at some actual ones. So this diagram came directly from the SQLite docs. I didn't make this myself. But this is kind of how it works. So first you have the interface at the beginning, right? Those are your C functions that you call into. Even if you're writing SQL yourself, like in the SQLite 3 command line tool, it does go through these eventually. And that's things like opening the database, executing a query, preparing a statement, that kind of stuff. Then those go into the statements go into the SQL compiler. And this is kind of a unique thing in SQLite. Most databases don't do this. Most of them will have, a big tree of data structures that the query planner will use to decide how to optimize a query. SQLite takes a slightly different approach and actually compiles the SQL statements into bytecode that it then executes on its virtual machine. Something that's really interesting, if you really want to get nerdy about it, is in SQLite 3, if you prepend explain to any of your queries, it'll dump the bytecode from your query out, and you can read through and see actually every instruction that it's going to execute. And all the opcodes and everything are all documented on the website with detail and everything. So you can really, for optimization purposes, you can really dig down and figure out what's going on in any of your queries. So once all that's done, once you have this bytecode, it's on the virtual machine. The virtual machine, as part of the execution, will obviously hit the back end. The tables are all stored in individual B trees, which is a pretty common data structure for most databases. Most of them are B tree based. And then that data, those B trees are stored in pages using a pager very similar to like an OS pager. You can configure page size and things like that for optimization as well. Details we don't need to get into today. And then there's the OS interface, which SQLite calls the VFS, for the virtual file system, and that's pluggable, right? So there's kind of the default VFS, but you can make your own. There are also others that exist. An example of why you might want to do that is for encryption at the OS level. If you want to encrypt all the pages before they're written to disk, and as they're read from disk, you can do that in there. You could also use it if, say, you're on an edge IoT device that doesn't even have a file system, right? You can write your own VFS to write out to the file wherever it is. And then the last little bit here are the utilities and the test code. We talked about tests way too much to go into today. Utility-wise, there are multiple utilities, but the one you spend the vast majority of your time with will be the SQLite 3 command line tool, which is already on Mac OS. So you just type SQLite 3 in the terminal, give it a file name, or if you don't have a file, you can use an in-memory database. Instead of passing the file name, you do :memory:, and that'll make it a memory database. If you don't do that, you just type SQLite 3, it'll create a temporary database in the temp directory that you'll write to, and then it'll clean that up afterwards. All right, so that's what it is. We're finally to the last question. What can it do for me? Well, there's a lot of things, obviously. I wish I had a workshop worth of time to go through a lot of examples, but I'm going to try to go through a couple here and leave time for you guys to ask questions, and we can do a little live coding if you have questions that might relate to that. All right, so I'm going to start with an easy one. This is an extension to the language it was taken from I don't know which other database, I think a couple others, maybe Postgres, I think, does this. So there's an upsert. This is not supported by SQL directly. It's an extension in Postgres. It's been added in SQLite. It's pretty nice because it allows you to, it adds this on-conflict keyword down here at the bottom, the last line there. So, given you have this table called vocabulary that has a word and a count, whenever you attempt to insert something into the table, and word, because it's a primary key, that makes it unique. So this only works if you have a unique index or a primary. Actually, I think it only works on primary key tables, I should say. So, when you insert something into a primary key table, or a table with a primary key, if what you're inserting conflicts with one that already exists, then you have an option to do something. You can throw an error, you can ignore it, you can just write it, or you can, most likely what you might want to do is something like do an update, right? So then you get this set keyword, I guess you'd call it. You do, and then you can, it's not a good, I should have shown a slightly different example here, because you actually get the previous and the current values as well, like there's an old and new, kind of like, and it's like, you'll see it in the triggers when we get there. So you can test, I want this one, or I want that one. There's a lot of flexibility of what you can do. You can write anything pretty much in here, any query, for the most part. You can't do absolutely everything, but most things. So this is really useful if, say, you're syncing data from an API, right? You get a new JSON response from the API. You go to insert it, and there's already one there. Then you can just update what exists or throw it away or whatever you want to do. So that's upsert. Pretty useful, and I use it in pretty much most of the SQLite databases. Usually they're talking to some kind of API. Another one is the JSON extension, which is really fun to play with, and it's pretty fast and pretty kind of cool. So what I did to kind of use as an example for this is I just create a table here with just one column in it called JSON data. It's just a text field. So there's no JSON data type, right? Even though, because the JSON extension was added later to SQLite, and because the file format, remember I said that sometimes the fact that the file format can't change impacts implementations. This is one of those cases. Because adding another data type would require them to change the file format. They decided not to do that, and JSON is only stored as a text. And then all of the JSON extension are a bunch of functions that will parse JSON text and provide different things. And then we'll see what those are here just now. So this JSON right here is just an example. I went to GitHub, and this is a couple weeks ago, I grabbed the most recent 100 pull requests from the Swift repo using the GitHub pull request API. And just grabbed those JSON dictionaries and imported them all into a pull request database. So they're just, each JSON dictionary is in one row of the database. All right, so some things you can do. You can interrogate, right, the JSON. You can extract JSON or fields from the JSON. So this particular syntax, I did it because it looks nicer. It's new. It came out in 3.38, 39, SQLite, which is not, if you're targeting iOS 15, you actually can't use this syntax because it's new, unless you just build SQLite into your app, which is totally okay. Make your own copy of it. There was a function called JSON Extract, which takes two arguments. It would take the JSON data and then this key path, this JSON path, and it would return the same thing. But instead, there's this arrow, which is taken from Postgres. And it mimics what Postgres does. There's a double arrow and a single arrow. The single arrow will return a JSON version of the data. So if it's like a string, it'll actually have the double quotes around it. The double arrow will return a SQL data type. So in this case, I have this JSON that I pulled in. So all I'm doing is extracting it out, right? Extracting a couple fields out of the JSON dictionary. And you can see the result here, ordering by update. I didn't put the updated at because it didn't fit. I pulled it off. It didn't fit on the slide, but you could put that in there too, obviously. You can fetch anything. You notice the creator column that I have here actually drills down one level deep because there's a user object inside of that JSON dictionary. So there's a sub dictionary, which is the whole user object, and I just grabbed their login to put it in there. So you can really kind of query JSON and massage it a lot. This is really good for learning about an API, messing with some JSON. You can use it in real production as well if you want. It might be good for data, like data analysis as well. Large data sets, you get like a big ND-JSON file with a bunch of new line separated JSON dictionaries, slurp all those into a SQLite in-memory database, and you can start doing transformations and running SQL queries on it. So that's extracting values. You can also interrogate the JSON structure itself. There are a couple functions. I'm going to show one of them here because they're both very similar. One's called JSON each, and the other one's called JSON tree. JSON each will just give you all of the top level keys and their values, and it returns it as a table valued function. So it's basically a virtual table that has a bunch of information about each key. It'll have the value, it'll have the key path itself, it'll have the key name, and it'll have also the parent-child. Each column has a parent ID and its own ID and possibly a parent ID. So you can rebuild the tree that way. So what we're doing here is we're selecting from both the pull requests table and then this JSON each table valued function, which is another table. And then the full key is that entire key, as you can see there. I truncated this list. It was actually, I think, like 500 something, because there were some arrays, right? And so it was the array with the subscript for each one of those as well. So it ended up being like 538 or something. Didn't fit on the slide. You can also get the type. So those are some of the other pieces of it. So say you've been messing with this, like you're messing with this new API and you want to, it's time now to put it into its own, like put the data into a table, like the data you're actually going to use, right? And so you can create a regular table and move that data into it. So I'm going to do that because we're going to go on to another extension to learn more about it. So I'm going to, instead of having to do all this JSON data double arrow thing, it clogs up the queries. I'm just going to grab some of the fields and put them in their own table. So I created a new table called PRs with these, 7 different pieces, which I actually, maybe I don't need all of them, I don't know. Then I do an insert select statement, right? So the insert statement is what it sounds like, and then it'll take all the records returned in the select statement and insert those into the other table. All right, so this is me taking all that JSON data, getting just what I want, putting it into its own table. Now I could go drop the pull request table if I wanted and then move on with my life. All right. And so here's what we ended up with afterwards. So I just grabbed one of the records You'll notice I put this mode here for the SQLite command line tool. So the SQLite CLI has a bunch of configuration options for like how you display the data and all. You can do, there's lots of different things you can do inside of there. In this case, I did it line, so it does each item line by line. Otherwise, this would not have fit on the slide. And I also truncated the body because it was much longer than that. And it had new lines in it and stuff, so I just made it just a little bit. So you can see that it actually did what we hoped it would do. It took all of that data out of the JSON and put it in to the database. Now that I have this, maybe I want to learn more about the pull requests in the Swift repo. Maybe I want to search it. Well, there's a full text search engine built into SQLite. The latest one's called FTS5. There's also 3 and 4. I recommend using 5 if you can. They're not that different, but 5 is a little bit better. So the way it works is it creates a virtual table, then a bunch of kind of hidden tables that it uses for all of its indices. So the way you create your search index is you create a virtual table, and then if FTS5 is the name of the function as part of the extension. So you use using, if you're creating a virtual table from there's a specific API to make virtual tables, and that's what FTS5 is using. And so the using keyword is what says I want to use this virtual table function to make a virtual table. And so I'm giving it this PR row ID. I'm putting that in there so I can link back to the existing row in the PRs table. And then I just want the title and the body because that's the only things that really have text that I want to search. And that's what goes into my search index. Once I do that, I use the .schema command here in SQLite 3 to dump out what was actually created. And I removed everything except the stuff related to search index. And you can see there's the virtual table I created. And then beneath that, underneath that comment, you'll see all of the other tables that it creates for its indices. All right, cool. Now that I have that, let's do some searching. So before I do that, I have to actually put the data into the index, right? So same thing, insert select like we did before to actually get our PRs table, and now that data is all put into the search index. Now I can do a select, and the way you query a full text search is you do your regular select statement, and then in the from clause, you use the name of the virtual table and then your actual query, which is, there's a whole search query language similar to the Google search query language that you can use to do the query, but I'm just searching for concurrency here. But you can do, it's tokenized, and you can do all kinds of interesting things there. So I just want to see all of the concurrency, all of the pull requests that mention concurrency in the title or the body. There are 3. Those are the 3. So I got those, and you see the PR row ID is the row ID that I can use to fetch the whole pull request record out of the PRs table. Cool. Well, what if I search for a word like concurrent? Uh-oh. If this were Google, you would expect it would return the same thing, right? Or something similar. At least those 3 records would come back. Well, FTS5 can do this. You can configure the different stemming algorithms it uses for actually doing the search. The one that does the stuff that you probably want, it works pretty much only with English. It's called the Porter stemming algorithm. And so the way you do that is in the initial call to FTS5, you can add an extra parameter there called tokenize, and then you tell it what tokenizer you want it to use. The default is just to use like the standard UTF-8 one. So you add Porter to that. It's actually the Porter UTF-8 stemming algorithm. So now what I need to do is, so in order to do that, I need to drop my original search index. So I dropped that table. All those other related tables were deleted, created a new one, go back to insert everything back into the search index. Now I'm going to run my query again against concurrent, and I get the same thing back. So very configurable. You can do it however you want. There's lots of other options. You can get that from the document, the very good documentation. Another thing with the FTS5 extension is, you notice we have that separate table where we're keeping all of the things we want to index, all the different fields we want to index. Well, that table is not really connected to my original table in any way. So if you want to keep the index table updated, you need to do that yourself. And you can do that with something we talked about earlier, which are called triggers. So in this case, it's a little smaller than I thought it was going to be. I created 3 triggers, one for after an insert, after a delete, and after an update. These are pretty straightforward. So after an insert, we'll go and insert that row into the index, update, and delete, do similar things. So that's kind of how you would do a full text search against data maybe you fetch from JSON and turn into another table. I know earlier I got a few minutes left, and I want to go over this really quick because this is a feature I really like of SQLite, and I think it might be useful for many people. And it's using multiple databases. So I'll use that example I mentioned before. Like say I'm making an app that has where you can plan trips to airports, right? And so I have a table called trips in my trips database, trips.SQLite. It has a departure, arrival, departure time, and name. Notice there are no types. I don't care. I know what they're going to be. Doesn't matter. But then I also have this other SQLite table or database that I created that has a table in it, which I took a CSV that I got from the internet that has all of the airports in the world on it. I imported that into a table, stored it in its own SQLite file, and now I'm attaching that to my current connections. Now I have 2 schemas. There's one schema called main, which is the one from the main, the SQLite file you connected to at the beginning, and there's another schema which I named airports here with after the as keyword. You can name it whatever you want. And you can see that here, if you look at dump the schema again, you'll see the table trips. Main is implied here. It is main.trips, but that's implied. And then you'll see the other one, airports.airports. It's namespaced based on the name I gave it after the as keyword. So those are all the values there. So departure and arrival are things that I based off the ident, which is what you would normally see, like DEN, ORD, right, the code for the airport. So those are the 2 things I'm storing in the trips table. So you can see right here, I insert into trips my trip here, right? So I went from Hobby Airport to Denver. I'm sorry, it's not. I use the ident, which is actually not the normal person one. It's the one you would use as a pilot, right? All the U.S. airports start with a K, and then Canadian ones start with a C. They all have, each region has its own prefix. So I came from Houston Hobby to Denver International. That was my departure time, and I named it Flight to 360 IDEV. And you can see that's my row. But KHOU, KDEN, those aren't readable. I want to see HOU and DEN, right? How would I do that? Well, I've attached the database, right? So now all I need to do is I can select my trip, and I can join against the airports database now. So I'm doing 2 joins, one for the departure, one for the arrival. And then you can see the result here is I can now see actually what the name of the airport was that I flew into. So you can maybe see how this might be useful for you, especially if you have like data sets that are fairly static that you can use in your app to join with all other data that you might have. So I guess I don't have time for questions. I did hit it right at the moment, right at the exact time, but I am here for the rest. I'll be here till Thursday morning-ish. So feel free to hit me up on Twitter, on the Slack channel, or anywhere else. And thanks a lot. Sure. Which you'd pick? How do I decide? Okay, decide between like Firebase, Realm, SQLite, Core Data. I guess again, it's a use case specific thing, right? If if you need to take advantage of the Firebase cloud stuff, then it makes sense to just use that, right? Realm, probably the same answer. But if you're talking to another API that isn't that data store, then I would consider using either Core Data or SQLite. Now, whether you use Core Data or SQLite is kind of a personal choice and also kind of an architectural choice. With Core Data, especially if you're doing maybe like Swift UI views, you get the nice little fetch request you can use, which is really useful. But they're also, core data managed objects are also reference types, right? So they can be mutated out from under you. And so if that's something you're not comfortable with and you want all your data to be structs, or if you want to do more complex queries, or if you have weird join situations like this where you have, large, more static data sets you want to store, there are different reasons you might want to do one or the other, or you could do both, right? So say you have core data for like your kind of your main object store for all of your app data, but you want to add full text search, you can use a search index with SQLite, right? And you can just fetch your manage object ID, those URLs. It's not ID, it's something else. You can just fetch that or store that in your table as the ID, right? And then go fetch that back out of core data after you do your full text searches. So you can mix and match. You can use one or the other. You can use just one. It really is a use case specific thing. Yeah. So like, is there a Swift library? Because you can. I'll show you. Otherwise, you're going to end up doing something like this, which I can't see because it's not mirrored, but I know what it looks like. This is me. I actually wrote this. I didn't get a chance to get to this example, but this is actually I created a Swift function that I added to SQLite and called in a query. That was all the code it required to do it. But yeah, so calling the C API is clunky in Swift. We need to go now? Okay. All right, we're opening up. All right. So the answer, I'll tell you later, but really there's SQLite.swift, and there's another one called SQ something. It's made by Nike. They're both on GitHub, but SQLite.swift seems to be more popular, but it's a little more opinionated, whereas the other one is more, here's SQLite, do your thing. Anyway, that's it.